Okay, if you look at the triangle at the top of the page on page 43A and the triangle in 2A, there is a relationship between those two triangles. Well, first, they're both right triangles. But if you look at the scale factor between segment AB, which is 3, and the shorter side of the triangle in 2A, and if you put 6 over 3, and then you compare that to the ratio between the other leg of the right triangle, which is 4 on the one at the top and 8 on the one in 2A, and put 8 over 4, you would see that those both equal 2. So that means that the triangles are similar by side angle side similarity. So we can use the scale factor to find the missing side. Since the first one was 3, and if you double that, you get 6. The second side was 4, you double that and you get 8. The last side is 5. If you double that, you get 10. And that relationship is going to hold true for all of the triangles on this page. If you take 3 times 3, you get 9. 4 times 3 is 12. So that means that 5 times 3 would be 15. On this one, it's a reduction. You need to divide by 2. So if you take 3 and divide by 2, you get 1.5. If you take 4 and you divide by 2, you get 2. So that means if you take 5 and divide by 2, you get 2.5. Now in part D, we see a 0.3, a 0.4. So what's happened here is we've either multiplied by 1/10 or we've divided by 10, and we get 0.5. So all of these triangles are similar, which means that you can just use their scale factor to find the missing side. And so if we look at this last triangle on the page, let's see, we've got 3 over 4, and we've got 1. Well, 3 divided by 4 is 3/4. 4 divided by 4 is 1, so that means that our missing side here is 5 over 4.